right. Hello, everyone. So today's lecture is going to be over the notes for the ionic compound naming. So, excuse me. Essentially, this is the opposite of what we've been doing. We were going from the names to the formulas. Now we're going to flip that and go from you'll be given the formula and you'll figure out the name from that. Okay. So these notes are essentially a written out flow chart for the steps to doing this. So like you start with number one, you ask yourself, this question or whatever, can the cation form more than one ion? And then it tells you if yes, go to number two, if no, go to number four, and you just kind of follow it through. Okay. I'm not going to read through all of this just first. The easiest and the best way to do this is for me just to work on problems and walk through the steps as we do the problems. That's what helps it make the most sense. So I'm going to go to the examples that are on the back of the notes. You can just kind of, you can kind of follow along as we do it here. So let's see, what do I have here? Okay. All right. So the first example is Mg3N2. Okay. Now, one of the things that I probably should explain to you first before getting into this would be the idea that really when you're looking at a formula, the first thing you're going to do is figure out if it's covalent or ionic, or one of the ones we haven't done yet, acids or hydrates, but covalent or ionic. So this set of instructions is assuming that you already know it's an ionic compound, right? When looking at the formula, how do we know that? Well, the first element in the formula either needs to be a metal or one of the positive polyatomics for it to be ionic. Okay, anything else would be considered covalent or not ionic, depending on what it is. Okay, so we know all these are going to be ionic. So we look at our formula here, Mg3N2. And once we know it's ionic, the first question we're going to ask ourselves is, can the cation form more than one ion? Right? To know that answer, we need to go to our periodic table and we find the elements. So Mg is right here. Can it form more than one ion? The ones that form more than one ion are the ones that we don't know the charges to. So if we can figure out the charge by looking on the periodic table, it only forms one ion. So Mg is here. It's in the 2+ category. So that means it only forms a 2+. So the answer to number one is no. Okay, so, and this here just talks through some of the stuff we've already talked about, how to figure out if it can form more than one. So the answer is no, it does not. So we're going to go to number 4. Start by writing the cation name. Okay, so the cation name, Mg, is magnesium. So we just write magnesium. All right. If the cation forms more than one ion, go to number 5. If it does not, go to number 6. Well, we already said it does not, so we're going to go to number 6. Is the anion monatomic or polyatomic? So you look at the anion. Is there only one element, or is there more than one in the negative part of this? Well, there's only one element. So that would make it monatomic. If it's monatomic, change the ending of the anion to IDE. So this is nitrogen. So nitrogen becomes nitride. And that's it. That's the name. Okay. All right, let's do another one. K2CO3. Okay. Can the cation form more than one ion? So we look at potassium, K. Right here has a +1, so no, it does not. So we're going to go down to number 4. start by writing the cation name. So this is potassium. Okay. Does not form more than one ion, so we go to number 6. Is the anion monatomic or polyatomic? So we look in the negative thing, which is everything after the cation. So here, well, it's polyatomic. There's more than one element. How do we know? More than one capital letter. More than one element, that makes it polyatomic. We write the anion name with no changes. This is off of our polyatomic ion. So look on polyatomic ion sheet for the name. So we're looking for CO3. Okay, so we look on here and we just scan until we find CO3. Okay, here we go. CO3, -2, is carbonate. So we write down carbonate, no change. And there we go. That's the name, potassium carbonate. Okay. All right, let's take a look at the next one. I'm going to fold this over so we can follow along on the notes here. Okay. So we have Cu2S. So can that cation form more than one ion? All right, so let's look. Cu. Cu is here. We do not know the charge. It's not in a column, and we haven't labeled it with a specific charge. That means yes, it does form more than one ion. All right, so we go back here. Okay, so the answer is yes. Go to number 2. Okay, now let me just sort of explain really briefly why, like these next steps, like what we're trying to do and why we're asking, can the cation form more than one ion? Okay, so if you recall back when we were going from the names to the formulas, if we were ever doing one where actually, I'm going to pause for a second and grab one. Okay, so this is from the notes from the other day. So if we had a name where the cation, like here number 4, iron 3 oxide, where the cation, if we looked up iron on our periodic table, Fe, we don't know what the charge is, right? So in order to make the formula, we need to know that positive charge. So in the name, they had to give us a Roman numeral to tell us what the positive charge is. Okay, so when we're going back the other way, if we have one like we do here with copper, where they can't look at the periodic table and know the charge, we have to, in the name, give a Roman numeral to tell what the positive charge should be, because there could be more than one. All right, so this is kind of difficult until you get it down. But basically, the way we do this, all right, is we do sort of a reverse crisscross to find the charges. Okay, so remember to only bring up numbers outside of parentheses on polyatomic ions. If there are no parentheses, a 1 is brought up. So there's no polyatomics here. So we are going to bring up, I'm just going to rewrite it a little bigger so you can see how we do this here. Okay, so you just essentially undo the crossing. Okay, so this would turn into Cu. Remember, the first thing is always positive, second one is always negative when you bring them up. So the thing on the copper is going to be positive, so we're bringing up a 1, so it'd be +1. Up onto the sulfur, we're bringing a 2, so it'd be -2, like this. So that's step number 2. Okay. Then, step number 3, check the anion charge for reduction. Okay, the way we do this is we compare the reverse charges to the expected charges either from the periodic table for monatomic anions or from charts or online for the polyatomic anions. So we're looking at the anion, the negative thing. So according to what we have here, we have sulfur as a -2. Pull it up a little bit here. We have sulfur as a -2. So we look on our periodic table. What does our periodic table say sulfur should be? Sulfur's right here. It should be a -2 compared to what we have. That's what we have. That means that these were not reduced. Okay, this is what they were originally supposed to be. So, okay, if they're not reduced, go directly to number 4. So we go to number 4. Start by writing the cation name. Okay, so it's copper. If the cation forms more than one ion, go to number 5. Yes, it does. We already decided that this forms more than one ion. Number 5, add a Roman numeral after the cation name to indicate the charge on the cation. Okay, so our charge on our cation, or positive, is a 1. So after copper, we write in parentheses Roman numeral 1. That tells the people what the positive charge is for the ion. Okay, then we go to number 6. Is the anion monatomic or polyatomic? Our anion is monatomic, just sulfur. So we change the ending to IDE. So sulfur becomes sulfide. So the name for this is copper 1 sulfide. All right, let's do another one. CONO32. Okay. Can the cation form more than one ion? So we're looking at the positive thing at the beginning here, CO, cobalt. So we find it here. Yes, it can. We don't know the charge, so that means it can form more than one ion. Okay, so we go to number 2, reverse crisscross to find charges. So now here, okay, remember to only bring up numbers outside of parentheses on polyatomic ions. Okay, so let me move this up a little here. All right, when we're reversing, the NO3 was one thing. That's a polyatomic. That all stayed together. So you can't undo any of that. So you're only bringing up numbers outside of parentheses on a polyatomic. Okay. So we end up with CO. Remember, first thing is always positive because that's the cation. So we're bringing a 2 up onto that, so it's +2. And then NO3 is our polyatomic. The 3 stays part of that like this. And from the cobalt, we're bringing up a 1. So second thing is always negative. So -1. Okay. Now, check the anion charge for reduction. Okay, so NO3, -1. So we got to look at our polyatomic. So we find NO3 on here, see if it's a -1. Here we go. NO3 is a -1. So it was not reduced because it's the same. We have the same thing here as we do on the polyatomic sheet, so it's not reduced. Okay, so start by writing the cation name. So the cation is cobalt. Okay, add a Roman numeral because we had more than one ion for cobalt, so 2. Okay, and then is the anion monatomic or polyatomic? It's polyatomic. If it's polyatomic, write the anion name with no changes. So we look on our polyatomic ion sheet. We already looked it up down here. NO3 -1 is nitrate. So we just write nitrate. So the name of this one is cobalt 2 nitrate. Okay. All right. Let's move on to the last couple of examples here. And by the way, just so you guys know, when I do examples, I try each example to be a little different, like an example of something you might run into that would be a little different each time. I try not to double up too much. So there is some good to watching through all the examples. Okay. FeO. So does the cation form more than one ion? So we're on Fe. So we look at Fe. Yes, it does. We don't know the charge, so yes, it does. Okay, so we're going to reverse crisscross to find the charges. So FeO, there's no number, so just a 1 and a 1, so we get Fe plus 1, O negative 1. Okay, now check the anion charge for reduction. So I've got O as a negative 1. Okay, so I look at my periodic table. O, according to my periodic table, O should be a negative 2. That doesn't match what we have. So that means it was reduced. If it was reduced, multiply both charges, the anion and the cation, back to the original charges. So, in other words, O is supposed to be originally a negative 2. So you ask yourself, what do I multiply by to go from a negative 1 to a negative 2? What number do I multiply by? Well, I multiply by 2. So if I multiply this by 2, that means I have to multiply this by 2. Positive 1 times 2 gives me positive 2. So we started off with Fe plus 2O negative 2. Okay, and if you look at it, it makes sense. If we had this and we were trying to make the formula, before we cross down, we would reduce those or simplify them, right, to a plus 1 and negative 1. So we would have reduced it. That's what we're finding out here. All right, so start by writing the cation name. Iron. Okay, it does form more than one, so we're going to add a Roman numeral. Iron, originally, you go to what we figured out was the original number, iron 2. Anion is monatomic, so we change the ending to IDE, so oxygen becomes oxide. So it's iron 2 oxide. All right, last one. CrPO4. Okay. Can the cation form more than one ion? Cr. We look it up. Yes, it can. We don't know the charge. So reverse crisscross to find charges. Okay, so on this one, now, let me write it a little bigger so we can see more easily. Remember to only bring up numbers outside of parentheses on polyatomic ions. If there are no parentheses, a 1 is brought up. So here's why. PO4. That 4 is part of the polyatomic. It doesn't change. That did not cross down when you're making the formula. Okay. The reason we know this is because we have a polyatomic, more than one capital letter, which means we have more than one element. If the 4 would have come down, it would have been outside of parentheses. But since it's not, we know that it was already part of this. So when we are undoing the crisscross, if it's a polyatomic and there's no parentheses, we're just bringing up a 1. Cation, anion. This is a negative 1 because there's just a 1 there. Okay. Or nothing there, so it's 1. All right. Next, check the anion for reduction. So we're going to find PO4 on our polyatomic ion sheet. Okay, PO4 is down here. PO4, 3 negative, negative 3, is phosphate. Okay, oh, sorry. We're checking it for reduction. So PO4 should be a negative 3. Our PO4 is a negative 1. So PO4 needs to be a negative 3. So what do we multiply by? We multiply by 3, right? So whatever we do to the anion, we got to do to the cation. Multiply times 3. We get positive 3. Okay? That's what it was originally. Now, start by writing the cation name. So Cr is chromium. Okay, we need the Roman numeral because there's more than one ion. So chromium was originally a +3, so Roman numeral 3 in parentheses. And the last anion is polyatomic. We already looked up the name. PO4 negative 3 is phosphate. So we just write down that with no changes. So it's chromium 3 phosphate. Okay. All right. I showed this in another video, but because we're doing the ionic naming, I'm going to show it again. And that is Roman numerals. Okay, Roman numerals, we have the ones that most everybody knows. 1, or I, it looks like I, but it's 2 and 3. This is, so that's 1, 2, this is 3 for Roman numeral. Then the one that people aren't always as sure of, looks like IV, and then 3. Okay, so the way this works is IV means, so V is 5. IV is 1 less than 5, so this is 4. VI is 1 more than 5, so this is 6. Okay, and then VII would be 7. VIII would be 8, like that, so on and so forth. Okay, so those are the Roman numerals. All right, that's it for this one. As usual, if you guys have questions, text me, or get on Google Classroom. Other than that, good luck.